Again, welcome to CS628 class, Data Science. These lectures cover the objective for week 6, which is based on, again, stat computation. In these lectures, I'm going to cover the concept of correlation. Now, we know in statistics, we have two types of correlation, and the PSC correlation and also the Spearman correlation. Now, the concept of correlation is that we want to find out if there's a relationship or association between two values. So normally we can start with a scatter plot and we can find the pattern. So here we say correlation analysis is when two factors are correlated, when values of X has some predictive power on the value of Y. So normally when we are doing regression, which will be our next topic, we first of all will start with the correlation analysis. Because in regression, we want to know if, for example, X variable predict Y, or let's say cigarette smoking predict that a person may get lung cancer. Now, in order to say that X may predict Y, that means there may be a relationship already between the two, or association between X and Y. So to do, again, regression, we start with a correlation. So here we say the correlation coefficient of X and Y will measure the degree to which Y is a function of X. And when we use the term, the measure of degree means, again, the strength of the relationship between X and Y. And normally the correlation value ranges from -1 to 1. Now, when it's -1, we normally say there's a decreasing relationship, which means, for example, if X increase, Y would decrease. Or if Y increase, S would decrease. Now, if it's +1 or close to +1, we say they have increasing relationship, which means if S increase, Y also increase. For example, the more cigarettes you smoke, the more higher chance you have to get a lung cancer. Now, if the value is 0 or close to 0, then in this case, we don't have no relationship. So here we say uncorrelated. There's no relationship between the two variables, X and Y. So as we said, we have two types of correlation. We use the PSC correlation if our variable is quantitative, or it's a ratio, again, it's a value, a raw data. I will use the term raw data. Then a Spearman correlation can be based on ranking, for example, ordinal data, etc. So here we see a PSC correlation will evaluate the linear relationship between two continuous variables. So again, the variables must be a raw value, Then the Spearman correlation evaluates a monotonic relationship. And here we say the Spearman correlation coefficient is based on rank values for each variable rather than a raw data. So a raw data is for PSC value, actual value. So this is the formula to find the correlation coefficient. Again, this is for PSC. So you can see that in PSC, by looking at the formula, we can see that we are using multiplication operation. We're also using a difference operations, etc. So here we can see that again. And also even we have to find the mean value for both variable of X and Y. So this means our data cannot be ordinal or nominal. It have to be a raw data. So again, to find the R, we find the mean of X value, also the mean of Y. And here we say HXI means I will be the starting of the, for example, here we say the sum I equal to 1 to N. So which means the sample size is N. So we may have I1, I2. Let's say the sample size is 3, then we may have I1, 2, 3. So this means we have to find S1 minus the mean times Y1 minus the mean plus S2 minus the mean times Y2 minus the Y mean, and then times, again, the last section plus X3 minus X mean times Y3 again minus Y mean. So that is the summation the size of the sample is n. So again, by looking at this formula, we need, again, a raw data or continuous variable quantitative. As we said, the R value will always be between -1 to +1. Then we can make our translation. So here we say the point SY makes a positive contribution to R when both are above or below their means. Now, these are some few examples of a PSC correlation. For example, we can say that the SAT score and the freshman GPA, the correlation is 0.47. It's kind of a weak, I would say a very strong increasing relationship because it's almost 0.5. Now, if it's 1, that would be perfect increasing relationship, which means if your SAT score is high, your freshman GPA will be high also, will be good. But here it's kind of a weak increasing relationship. Since 0.47 is positive value, again, it's increasing relationship. Also, we have SAT score and also economic status. Also, it's 0.42. So it's an increasing relationship, but weak. Then income and coronary disease. Here we can see it's negative 0.717. This is very important because this means that if a person's income is low, if I have lower income, the chance of getting the coronary disease is high because this is a decreasing relationship, negative. So income is low, coronary disease will be high. Income is high, the coronary disease will be low. Another example is smoking and mortality rate. Here we say that 0.718, so it's an increasing relationship. Video games and violent behavior is very, very, very almost close to 0. So there's no relationship between video games and also violent behavior. So how do we interpret correlations? We can find, after we find the R value, we can find what we call the R square. So here we say the square of the sample correlation coefficient, which is R square, will estimate the fraction of the variance in Y that is explained by X. Here we are assuming Y will be our output variable, X will be our input variable. This is in terms of regression, in a simple linear regression. So here we're going, for example, if R is, let's say, 0.8, R square will be 0.64. So we can say that again, 64% fraction of the variance in Y explained by X, 64%. This is for again regression. Now, there's a major difference between regression and correlation. In correlation, we just want to find the relationship between two variables. So we don't care about which variable is the independent variable, which variable is the dependent variable. It doesn't matter. But when we are doing regression, it's very important. Here we have to make sure that X will determine Y. So for example, smoking cigarette will determine if you are going to have a lung cancer. We cannot say lung cancer will determine if you are going to smoke. That means I'll get a lung cancer first before I decided to smoke. So So here we say that the predicted value of a correlation decrease quadratically with R based on the formula here. So the correlation between height and weight is approximately 0.8, meaning it explains about 2/3 of the variance, of the difference. Now, we also can interpret the correlation in terms of the significance. So we say the start significance of a correlation would depend again on upon the sample size as well as the R value. So here we say even a small correlation becomes significant at the 0.05 level with large enough sample size. And we also know that in hypothesis testing or even regression analysis, sample size is very important also. So sample size may have effect on the outcome. So that will take it to Spearman rank correlation. As we said earlier, Spearman also will find the correlation between variables, two variables. But again, here everything is based on ranking and also the counting. So here we say Spearman rank correlation will count the number of disordered pairs, but not how well the data fits a line. So better with the nonlinear relationships and also the outliers. Now, this is the formula. So here we say again, let rank xi be the rank position of xi in sorted order from 1 to n. So n will be our sample size. So to find the row, it will be 1 minus 6. Now the sum of di square, again, I will start from 1 to n, divided by n times n squared minus 1. Now, what is di? Here we say where the di will be the rank of si minus the rank of yi. Again, our next lectures, we're going to do some manual work, solve a manual example. Because here you're going to have two data sets, x and y. So to find the d, it will be the difference of those two values, the ranking. But it is a PSC correlation of s and y value ranks. So it's the same concept, Spearman correlation, -1 to 1. Now, correlation versus causation is a very straightforward. It's correlation. If we find out that there's a relationship between s and y, does that mean that there's s will cause y or y will cause s? The answer will be no. The reason why, because again, we may have some few things when we are doing data analysis, for example, confounding variables or modification effects. So a confounding variable would be a third variable that will cause a relationship between two variables. An example would be, we had a data from Florida that during the summertime, ice cream sales go high and goes up, the sales goes up. And at the same time, shark attack also increases. The shark attack in the ocean also increase. Now, can we say that ice cream sales causes increase in a shark attack? So, which means if a person buy an ice cream, go to the ocean, it will be attacked by a shark. Or when a person attacked by a shark, it will go to the first thing it will do is to buy ice cream. So this is the concept of correlation versus causation. The answer will be no. There's a correlation between shark attack and also ice cream sales during the summer in Florida. But that doesn't mean shark attack causes ice cream sales to go up or down. But rather, the confounding variable, in this case, it will be the temperature. So when the temperature goes up, ice cream sales goes up. But at the same time, again, in the ocean, the water is very warm, so the shark come closer to where people are swimming, and that may increase. So that's the whole concept. Correlation versus causation, yeah, there will be a correlation between two variables, but that doesn't mean there's a causation. So we say correlation does not mean causation. Example given here, the number of police active in a precinct will correlate strongly with the local crime rate. So if we know an area, the crime rate is high, maybe the government will have more police officers to patrol the road, which is good. But the police do not cause the crime. So there's a relationship between the number of police officers patrolling the road and the crime rate. But that doesn't mean the police, the number of police causes the crime rate to either go up or down. So that will be the conclusion of these lectures. Again, these lectures we could focus on only the theory concept of correlation. As we said, there are two types of correlation. There's PSC, which is based on quantitative, and also Spearman, which is based on qualitative or ranking concept. So normally in general statistics, and we may say a PSC is a parametric testing, and a Spearman is a non-parametric testing. So see you in the next lectures, which we will discuss about regression analysis. Then after that, we will do some examples using the Python to solve those problems on correlation and also regression. Thank you.